All right. So, final answer, A plus C divided by 2. Is that what y'all got? Okay, so if we drew a picture, triangle ABC with A, B, and C, and then it says that ray BD bisects the exterior angle at vertex B. So ray BD bisects the exterior angle at B. So if it bisects, I have arc, arc. So first you would use the exterior angle theorem. This whole angle is A plus C. But that angle was bisected, so the answer is A plus C divided by 2. Any questions? Homework answers. These are on multiple slides, so this is just 1 through 4. Check your answers quickly, please, to 1 through 4. I know there was a lot of writing. Yes, I know. It is important that you got this part right. Does your answer have to be word for word what's on here? No. You could have, there's a few things you could have switched around, but the truth value, you should be getting all the truth values right. Here's 5 and 6. Like I said, let's really look at the truth value. If you got the truth value right, you probably don't need to look at the sentence. So there could be a question on the test that says, is the truth value of the contrapositive of this conditional true or false? Or like, what is the truth value of the contrapositive of this sentence? So you'd have to first write the contrapositive and then decide if it's true or false. So that's why we're training you with these. No, Aaliyah, good question. So I told you that the original and the contrapositive are always the same truth value. I told you that the inverse and the converse are always the same truth value. But they're not always opposite. They could all 4 be true, and they could all 4 be false. So that's just how this, the sentences I chose for this homework just worked that way. And final page. That was a lot of pages of answers. 7, and then it skips down. I put 8 at the bottom. I didn't do 9. Number 10, there's multiple answers. Over to the segment, and you quote-unquote measure it with your compass. You open it to how long you want each side to be. So I've done that. So then you hold on to that compass setting, and you put the needle at your center, and you draw a circle. Now, after you draw a circle, the next step is to draw another congruent circle where the pencil goes through the center of the original circle. So I moved my compass over. It still has the same radius. I need to make a note of where my needle is. That's really important to put a dot where your new needle location is. And then you make another circle. This other circle needs to go through the center of your original circle. Now I have 3 points. I have my original point. I'll just call it A. I have my point where my needle was the second time, and then I have the point of intersection. This is a radius, and a radius. They're all going to be congruent if they're all radii of congruent circles. So that's how you construct an equilateral triangle, the way the textbook shows it. So title your notes, Special Segments and Triangles. You don't have to write this in your notes because we're going to go through those one by one. So just label it Special Segments and Triangles. There's 4 of them. We're going to talk about what each of them does. They each have a job. Special Segments and Triangles. All right, so take a look at what I have here. I have the 4 special segments, a picture drawn of them, and then I have the 4 words. Oh no, it's opening up weird again. It didn't do that on my other lesson. Well, that says median, and the Smart Notebook software is squishing my text for some reason. Pretend that says median, which it really does. Okay, so I put them out of order. These are not in the right order. So I want you to use the markings on those triangles to see if you can guess which word goes with which picture. I'll zoom in a little bit more now. So which word goes with which picture? This one's probably the easiest to pick first. That one, what are my symbols showing? My symbols are showing there that that angle is getting cut in half because it has arc, 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 arc. So that one is our angle bisector. Let's see. This one we've seen before. This one's both perpendicular and it's cutting the side in half. So that one's probably going to be our perpendicular bisector. So now we have two left. We have median and altitude. And we have two triangles left. Well, median kind of sounds like a midpoint, right? They'll start with an M at least. Median will go through a midpoint. So our median is going to be this one down here, where C is the midpoint of the opposite side. And then our altitude needs to be perpendicular. So we'll learn more about that in a minute. Just wanted to see if you could use your prior knowledge to connect those to the right picture. Let's look at this one first. Write this down in your notes. Write down perpendicular bisector. We had a whole lesson on this before, except it just wasn't in the context of a triangle. So now we're putting it in a triangle. A perpendicular bisector is a line, segment, or ray that's perpendicular to the segment at its midpoint. So there's two words in this special segment, and each word gets a symbol. Perpendicular means add a 90-degree angle marking. Bisector means add tick marks. So we're going to take a side of the triangle, and we're going to draw the perpendicular bisector of that side. Okay, so on this slide, you're not doing this slide in your notes, so you can just watch for this one. On this slide, I drew three different triangles specifically. I drew an obtuse triangle, I drew an equilateral triangle, and I drew a right triangle. I want to show you what the perpendicular bisector looks like in all different cases. So it says draw the perpendicular bisector of BC. So how would we begin? We would begin by finding the midpoint of BC. I'm not going to find it exactly. I'm just going to eyeball it. So to be a perpendicular bisector, you would need to go through a midpoint. And could I do that? No. To be perpendicular, I would need to try to go as straight as I could, perpendicular to BC, as vertical as I could. So that's what it would look like on our obtuse triangle. Something special is going to happen on our equilateral triangle, as you can imagine. It's going to go through an angle. And on our right triangle, nothing too enlightening, nothing too special. Looks like that. So what could we conclude about when a perpendicular bisector would go through a vertex? When do you think a perpendicular bisector would go through a vertex? There's actually two times. What do you think? Equilateral, and you guessed it, isosceles, yes. So a perpendicular bisector, these are called the special cases. It will go through a vertex if and only if the triangle is isosceles. And when I say it's isosceles, that also means, sorry, when a triangle is equilateral. And when I say equilateral, that's also including isosceles. Both of them. All right. Next word, angle bisector. Same deal. We've talked about angle bisectors, but we were talking about it in the context of just angles. Now we're going to talk about it in the context of a triangle. Nothing too exciting happens. It simply divides one of the vertices into two congruent angles. One of the angles into two congruent angles. So every time you see angle bisector, you add arcs to your picture. And that's pretty much all I have to say about that. Okay, so let's see what that would look like in each one of these. So in my obtuse triangle, I would start at angle B because the directions tell me to, and I would bisect that angle. In this one, I would start at angle B and I would bisect the angle. And then this one, start at angle B and bisect the angle. Now, just because I'm bisecting the angle, does that mean that I'm bisecting the side too? Good. 45, 45 over here. Good. Just because I'm bisecting the angle, does that mean I'm bisecting the side? Well, it does mean I'm bisecting the side for two special cases. And what do you think those two cases are? No surprise there. When would an angle bisector also cut the side in half? Also be a perpendicular bisector. And there's nothing new behind my two doors. It's the same answer in an isosceles and in an equilateral. So in the other ones, it did not cut this in half. It did not cut this in half. Well, we'll leave it at that. Yeah. If that's not an isosceles triangle. Okay? So this one did. The other two, not necessarily. Could have, but not necessarily. It would have to be isosceles. Next word. This is a new word. Well, in geometry, it's a new word. You've heard it in other maths, mean, median, mode, range, right? But this is going to mean something totally different in geometry. A median is a segment whose endpoints are a vertex and the midpoint of the opposite side. Good, Neil. Median, middle. Median, middle. So, the key to this is just like an angle bisector. A median has to begin at a vertex. A median has to originate at an angle. So a median can't do this. Let me show you what a median can't do. A median cannot do that. A median must go through a vertex by definition. So I'm going to start at R, and I'm going to travel to the midpoint of the opposite side. C is a midpoint. That's not really the symbol for midpoint, but I'm going to use it to pretend like I'm abbreviating midpoint. Okay, so C is a midpoint, midpoint, median, median, midpoint. Yep. Neil's talking about, you've heard the word median in the real world, like when you're driving on the road and there's that concrete thing in the middle, or sometimes they plant flowers. That's the median. That's good? Yeah, it's in the middle of the road, right? It splits the left and the right of the road in half. Doesn't that mean that one line can be perpendicular bisector in a median? Well, only in two special cases, Pranav, yes. A median could also be a perpendicular bisector, but only in two special cases. I'll show you. All right, let's practice drawing the median from A to BC. Now, first, I would find the midpoint of BC. To draw a median, I would first want to locate the midpoint. Then I would connect A to my midpoint. That's what the median would look like there. Here's my midpoint. That's what the median would look like there. And here's my midpoint. This is what the median would look like here. Most of the time, your median is going to be kind of diagonal. It's going to be diagonal. Most of the time, it's not going to hit the opposite side at 90 degrees. 2 of the times, it will hit the side at 90 degrees. And it's no surprise.
This is for 9th grade teachers only. If you have 9th grade students,
when would a median
NHI meeting this morning
also be an angle bisector
are being released right now.
And a perpendicular bisector?
Thank you.
When would it be 3 segments at once? And it's, of course, isosceles and equilateral, is when it does double duty, triple duty, in fact. Actually, when we get to the last segment, you'll see it's quadruple duty. All right. Altitude, last word. Once again, we have not heard this in geometry class yet this year, but you've heard it in the real world in altitude. In geometry, it's the perpendicular segment from a vertex. Did you see that? It's just like a median. It has to come from a vertex and then it's going to go to the line containing the opposite side. Now, you're probably like, why didn't they just say it goes to the opposite side? Why did they say it goes to the line containing the opposite side? And we're going to figure out why in just a moment. I'll let you write it down. While you're writing this down, I'll just chat more to fill the space. But anyways, you might hear the word altitude if you've ever been on an airplane and the pilot comes on to like tell you how the weather is and whatever. And he's like, we're approaching an altitude of 10,000 kilometers or whatever he says. I don't even know how much that is. But your altitude is not, like when you're in an airplane, it's not how far you've traveled, right? If this is the ground, this is not your altitude. That's how far you've gone. This is your altitude. It is the perpendicular. It's the drop straight down to the ground. Be perpendicular to the ground. That would be your altitude. So that's why an altitude is perpendicular to the opposite side. Also, if you've ever been baking and you see some instructions, and there's two different instructions. There's one for regular baking, and then there's one for high altitude baking. So like when you're in the mountains and your altitude, your height off the ground is a great distance, then you have to use different directions for cooking. Okay, let's see what an altitude looks like for 3 different triangles. This is very important. Everyone needs to listen to this part. Draw an altitude from angle A. Okay, so I'm going to try and draw an altitude. Oh, I'm not 90 degrees. I'm not 90. I'm not 90. I'm not 90. Oh, no. None of those are perpendicular to the opposite side. So what do I have to do? In an obtuse triangle, I have to extend my side. My altitude is going to fall outside the triangle. In an obtuse triangle, my altitude is going to fall outside the triangle. So you know how the definition said, to the line containing the opposite side? I had to draw the line that contains BC. I had to extend it. So that's important. Nothing special here. All of the segments are the same. In isosceles or equilateral, all 4 segments are the same. And finally, ooh, what happens here? I'm going to start at A, and I want to be perpendicular to CB. Weird things happen with altitudes. The altitude is the side is the altitude. It's not in the triangle, it's not out of the triangle, it's on the triangle. So, you can write this down in your notes, or you can just memorize this. When would an altitude lie outside a triangle? When the triangle is obtuse. When would an altitude also be a side of the triangle? When the triangle is right. So, if it's other than obtuse and right, if it's an acute triangle, it'll fall inside. Those are the boring ones. These are the exciting ones, when something crazy happens. Okay? Going to move on because we need to get to some examples, and I know some of y'all already have to leave. All right, name and altitude. Which one's the altitude? We learned that an altitude is perpendicular to the opposite side, BF. Name a median. We learned that a median goes through the midpoint of the opposite side. Name an angle bisector. Yep. Cuts the angle into 2 concurrent angles, AE. Moving on. Classify the following segments. RQ. RQ is an altitude. SV. Now, this one's very important. I need everyone listening. SV is an altitude and it's a median. But you don't call it altitude and you don't call it median. You have to call it a perpendicular bisector. Okay? It's like calling a square a rectangle. Is a square a rectangle? Well, yes, it is. But is a rectangle the right word to call it? No. It's more than a rectangle. It's a square. So SV is more than an altitude. It's more than a median. It is a perpendicular bisector. So that's very important. So RU is a median because the tick marks give it away. U is a midpoint, so RU is a median. Okay? All right, we're going to end on this slide for you guys. You can leave after this. ED is a perpendicular bisector. So when you find out that a segment is special, you need to add markings to your picture. ED is special. So we're going to add right angle markings and we're going to add tick marks. Which of the following can be determined? They're not even asking us to find it. We're just asking which ones could you find. Okay? A, D, E. Could we find it? Yes, sir. Yes, ma'am. It's 90. AE. Could we determine AE? Does a perpendicular bisector cut AB in half or just AC in half? Right. We could not determine the distance from A to E because a perpendicular bisector, it's bisecting AC, nothing else. The measure of ABC, could we find that out, this angle right here? Do we have enough information? To find the missing angle of a triangle, you need 2 out of the 3 angles. We don't know C, and we don't know B. So no, we can't determine. The distance from A to C, can we determine it? Yes, it's 22. AED, can we determine that angle, angle 2? Yep, because we have the 90-degree angle marking. Yes, we could determine. And ED, can we determine the length of the perpendicular bisector inside the triangle? Nope, we don't have enough information. Now, if we knew AE, we could use Pythagorean theorem, but we don't know AE. So that would be a big old no. All right? Number 2, FM is 6x plus 10. MR is 8x minus 5. And FR is 75. Find X. Then determine if AM is a median. So we're going to do what we learned first 6 weeks. We're going to do segment addition postulate. We're going to do part plus part equals whole. 6x plus 8x is 14x. 10 minus 5 is 5. So 14x plus 5 equals 75. 14x equals 70, and x is 5. So now we plug it in. 6 times 5 plus 10. FM is 40 units long. 8 times 5 minus 5. And MR is 35 units long. Is AM a median? And the answer is no, because M is not the midpoint of FR. So it looked like a median, it sure looked like it cut that in half, but the math, the algebra said no. So the answer to the problem is literally just no. If NM, something happened to my picture. Hold on a second. Did you like my sound effects? That's how it was supposed to look. If NM is an altitude of NOP, solve for X and solve for the measure of angle 1. So every time I tell you a segment is special, you need to add a marking to the picture. Never begin solving until you've added a marking. What marking does altitude get? 90 degrees. And altitude intersects the opposite side at 90 degrees. So you need to add that to your picture. We are not going to use the 2x. That is extra information. We are going to say that 4x minus 14 equals, we know exactly what it equals because of the word altitude. It equals 90. So 4x equals 104. X equals 26. Now that we found X, we did this part, check. Now I need to find the measure of angle 1. So we're going to take that 26 and plug it in. 2 times 26, so this angle is 52. This angle is 90, so now we can find this one. Did I talk about with you guys when you have a right triangle? The two acute angles always add up to 90. It's just a shortcut. We can just do 90 minus 52. And the missing angle is 38. So when you have a right triangle, you don't need to add them up and subtract from 180 every time. You've always used up 90 degrees. You always have 90 degrees left over for those two angles. So 90 minus 52 will get you there. It's a good shortcut that you'll use a lot. OL is a perpendicular bisector. I need to add two things to my picture. For perpendicular, I need to add a box, and for bisector, I need to add tick marks. GA is 12. OL is 8. And the measure of angle A is 53. We need to find log. So we need to find this angle right here. And we need to find OG. We need to find this side right here. The cool thing is we don't need to solve for x at all. We don't need to solve for x. What triangle is OGA? What kind of triangle is it? Do we know? Well, when a perpendicular bisector goes through a vertex, story over, game over. It is at least an isosceles triangle. It could be equilateral. I don't think it is in this case. Well, it's not in this case, actually. But it's at least an isosceles triangle when a perpendicular bisector goes through a vertex. So that's really important. Okay, so first we can take this 12 and we can divide it by 2, 6 and 6. And now I have this triangle right here. I've got 8 and I've got 6. If I pull this out and I'm looking for this. So to find OG, we can use an old theorem. We can use good old Pythagoras. We can use Pythagorean theorem. 6 squared plus 8 squared is 100. Take the square root of 100. The answer is 10. So OG is 10. Find the measure of angle LOG. Well, if this is isosceles, then the base angles are congruent. So if that angle is 53, then this angle is 53. So if we look at this triangle, all we have to do is 90 minus 53 for a grand total of 37 degrees. Not bad. Yay, we made it to the end. All right, you have an assignment today. We have a quiz over, let's see, triangle inequalities tomorrow, and there's a construction on there, and there's a little bit of logic on there from the logic lesson. But there's a word bank. All right?